Hello and welcome back to our DAG node. Today we're going to focus on the testing setup. It's been a bit of a busy week at work, so I'm going to try and get my mind back into this quickly because I haven't looked at this code since last week. And it's a little bit late right now, but first world problems. We're going to try and bust through this and show the amazing power of Python again. But okay, let's get kicked off from where we left. God, I was going to say like from whence we left, like a Victorian or like a medieval, like God knows why. Tiredness is a funny thing. All right, let's start off with our awesome IDE PyCharm. You should see a little tick in the top right. This will highlight any syntax issues. You should have like a little warning sign or a little highlight essentially showing if you've got any issues. And if you haven't, you get a little tick that just says everything's great. But first things we're going to do, just to make sure that now we've created our DAG node, we're going to go and we're going to run our tests as they stand currently, just to make sure we haven't broken anything or that nothing's kind of failing that we can see already. So let's open up our Maya. And if you remember from our utils testing module, we're going to import test all modules. And then what we're going to do is just run our tests. Brilliant. So our 26 tests that we've already got, they ran in 0.088 seconds. That is awesome. Okay, we have no errors. We've got no failures. That is brilliant. Okay, what we want to do as well, we want to have this code a little bit more accessible. So what we're going to do is you can either create a new shelf where you have your tools, or you can highlight the code, middle click, and you can just drag it up here to the rigging shelf. And what we're then going to do is we're going to go edit. And you can see our code here that we just dragged up with the middle drag. So middle click and drag. It knows it's Python because we dragged it from a Python window. We will open up shelves. And what we're going to do, we're going to get rid of the background transparency. And we're also going to put this called test so we can see it quite clearly. And there we go. Let's see how this looks. Test. Let's make the background black as well. No, that's the text brightness. That's incorrect. But why are you not showing? Oh, one transparency. I meant the other way. So, test. Okay, perfect. So now if we clear that output window, we put test, then perfect. Okay, we're running all our tests automatically from a little click of a button. And this is the fun part, trust me, because you are literally putting days, weeks of work into a click, and it only gets better from here. Once you start building rigs at the click of a button, you start importing guides at the click of a button, you will literally just feel the beauty coursing through your veins, because it is just awesome being able to put weeks and weeks of work into a click, into one button, into your index finger on your left or right hand, depending on your preference. It is what makes us powerful individuals in a company. And if a company doesn't have us, then more for them. Okay, it's why you should be finding it easy to sell yourself in the future. Not having you as a company is a bad mistake. You should have developers. The more the better. Okay, obviously to a point. But if you don't have technical people in your department automating tasks and automating stupid tasks, then you are just wasting people's time every day with monotony. But I digress. Let's get back. We've got plenty of tests to be getting through. So let's open up our tests folder within our modules nodal folder right next to base. So open up test. We've got our test dep node. We're going to right click on test and go new and Python file. And this one we are going to call, surprise, surprise, test DAG node. All lowercase. Perfect. So now, okay, let's open up our test dep node. Let's copy in a few bits. Test DAG node, let's copy and open. And you can actually set these things to auto-populate, but we'll maybe save that for a tutorial in the future, so that every time you create a new file that, within this project, you'll auto-populate with this doc string and maybe imports if you need. But what do we'll probably, yes, we're going to need my commands. We're going to need unit test, and we won't need nodal because that's not the part of the directed acyclic graph we're testing. We're testing DAG node. And because we have put DAG node within the initiate, within nodal, we can automatically just call that item. Now we're going to look at some really cool ideas. We're actually going to look at we're going to break this into several classes to test the various aspects of our DAG node here. We're going to start off with a test base class. So we're going to actually use inheritance within our Python structure here to kind of abstract a little bit of the nonsense away, because we're going to need to test some of our functionality with a lot more than maybe another part of our functionality within our DAG node. There's no point in within all of our tests maybe building 30 groups, or maybe creating 20 joints. If you're not testing any joints, then that's just wasting build time and essentially slowing your test down. So what you can do is build a series of base classes to abstract all that kind of difficulty away. And let's start off with our first base class. Perfect. Okay, so we'll just pause here for a second and you can copy this code out. Now, what we're looking at here is the base class that sets up and tears down, destroys all the objects that we are going to need. Well, we haven't done the tear down yet, but we'll do that in a second. But what we're doing here is we're setting up everything that we might need within our next series of test structures. But if we put it in this class, then we can just inherit it straight to the other classes, saving us having to rewrite this code, but also allowing us then to rewrite those methods, and add slightly more functionality while inheriting all of this. So let's go through and write the teardown quickly. Perfect. Okay, so we have our teardown as well, and our teardown will again check if everything exists. And then if it does, it will delete it. So in any cases where we maybe rename the item, or if we set sphere to being to equaling the joint, then obviously it will lose the connection to the DAG item in Maya that it is connected to, while being then having two items that are actually connecting to the Maya joint. So what we then need to do is just make sure in the classes we always delete things within, the functions that we are running. So to keep our test function or a test scene nice and clean. But we will test this as we go. So here we go. We have our base class. Now, again, as I said, these are really powerful things. If you know you're going to be testing within utilities, you might have pipeline code, you might have file systems that you're also using that is your responsibility to make a series of tests that copy a test folder out to an area, save a series of files, have a bunch of string information in them. Make sure that you have different test classes for different items, just to save yourself writing new tests. Then you can literally just inherit the test setup and teardown and write the test as you need to, rather than, again, writing an extra 20 lines of code that you might not actually need to use. It's just another way of abstracting a little bit of difficulty within the Python hierarchy. But let's get started with our first test for the DAG node. We will call this first test test DAG node. Here we go. And then what we want to do is now just start straight away and write test underscore DAG node underscore string. And ready to go. Because we are going to inherit everything from the test DAG node base, don't need our unit test now. What we're going to be able to do here is very simply copy this teardown and set up straight away, making it, saving us all of that code straight before the first test. Nice and simple. Okay, well, let's actually do what we did before. Let's go through to our DAG node. And we will press Alt and J. Oh, no, sorry, I'm highlighting the wrong thing. Click and highlight the def, or the define. Press and hold Alt and J. Cycle through, get each one of your functions. And then click forward to the beginning of the function name. And then hold down Control, Shift, and right arrow. And then press Control and C for copy. So now if we just literally copy. We get, wow, that's a lot of functions. Got out 40 odd functions there. Oof. Okay, we'll try to be quick through this today because I do love writing tests, but videoing it and talking about it, not so much. Got to try and make sure I'm a little bit more efficient with this. So, okay, we won't need to. We won't test our initiate again. So it's implied with the other tests. But we will test the repr, the string, and the equality dunder method. So we'll do that same as last time within our dep node. So we'll just change that to repr and to equal, just to make sure, or equal. Now, there we go. Okay, we'll just highlight these, encapsulate them so we don't keep on getting a red flashing lights showing at us. We will then click on the DAG, the dep node test, and we will now copy the isName equal to main. There we go. Let's put that right at the bottom. Delete the white space. And let's get started. Okay, I'll try and get these done nice and quick because there's nothing worse than wasting your life watching me write code. And I'm not good at doing multiple things at once, it turns out, so it wouldn't be great. Okay, great. We're in our first step. Let's test these 3 items and then go head over to Maya and see if they run and see if everything works as expected. So we first are going to test the string representation of our DAG node object, which again, we are going to use the, we are going to encapsulate the object itself with string and forcing it to give us the string representation, which then should come out now as the first item. So we are creating a sphere. We're not actually parenting it anywhere. And now, but because of that, it will actually say, well, this is the first item by which is indicated by having a pipe at the beginning. And that pipe indicates that this is a step within Maya. So if this was added to a group, you'd have a group called group 1. You'd have pipe, group 1, pipe, sphere. But because we are we're at the base level of our Maya inheritance or hierarchy, sorry, we will just get that pipe there. So let's now move on to our repr, which again, we can probably just copy over actually. Let's go up our test nodes, quickly pop over to repr, copy that code over, and then all we should need to do here is go DAG node. Okay, simple as that. And this again, we'll just test the string representation of the DAG node object. Now let's move on to the equal. Okay, perfect. So asserting with the equal, we are testing the equality operator of our DAG node, which has been inherited from our dep node. And we are going to test that these sphere DAG items are showing up as the same. Let's press Control S to save, Control A, Control C, and let's head over to Maya. So now let's press Control A, Control V, Control A, and Control Enter. Ran 3 tests. Okay, brilliant, perfect. Okay, we're starting off. Great. All right, now just another 40 to go. Let's try and bust through these nice and quick. Let's test our getter and setter for our node item. Let's just go and we can probably just copy these over as well and just see how we can append these. And I'm pretty sure this will test out exactly as we want, because again, we are getting the items, we are checking them against their name. And then we are also setting them. So we're getting the sphere node and we are then setting that to joint name. And then we are asserting that that node is the same as joint name. We are testing that that has gone through and it has been set. So let's again press Control S, Control A, Control C, jump over to Maya, then press Control A, Control V, and then we'll clear out the output window at the top with this clear history top window icon here. And then we'll press Control A, Control V, Control A, and Control Enter. Ran 5 tests and they all worked. Perfect. All right, let's test the DAG and the path now. And what I should say, obviously, is we need to make sure we press Control Shift Alt, and then we click on each one of these functions that we have stolen, test functions that we've stolen, and make sure we rename them to DAG, because we're not actually testing the dep here. Otherwise, that might be confusing if they ever error, and then we end up looking through the dep node for all the issues. These are the DAG tests. Okay, so we're doing test DAG node, and then node getter setter. But okay, we are now going to have a quick look at our DAG. And we'll also actually write the path out. What we can do, let's actually go through all of our items here. Let's highlight the comment, press Alt and J, scroll all the way down. And what we are going to do is just save ourselves a little bit of a headache. Tab in. Actually, sorry, we should remove the comment. We're going to tab in. So now we are within the class. Write def, and then test underscore dag underscore node underscore. Obviously, we will make some extra tests, but then press Control and right arrow, and then open up your parentheses, and then it should populate with self. What we will do here is just go pass. Okay, and enter. So now we have all of our tests named, ready to go. Perfect. Okay. Got 2 spaces, 1 space at the end, as per convention. And then we are ready to go. Okay, a little bit more efficient again. Okay, so for our DAG node, what are we testing here? We first actually want to make sure maybe that because we're using the DAG functionality, which is again using the OpenMire functionality, what we want to do maybe is test abstract in an abstracted way, just test that functionality. Okay, perfect. And let's remove this duplication. So what are we testing here? First, we are looking here that we're testing the DAG property of our DAG node. And what we're doing is we're creating a group. We're adding our sphere to that group. And then we're asserting equal to the self.sphere.dag path full name is going to give us the full name of the item. So as we spoke about, depending on the hierarchy, the pipe indicates the level that you are at within Maya. So we get pipe, offset, group we just created, and sphere geo, and then that should be equal. And then we are going to delete the group. So let's press save there, and then let's press press Control S, Control A, Control C, jump over to Maya. And then we are going to press Control A, Control V, Control A, and Control Enter. Run 46 tests, and we have an error. Ooh, let's have a little look. Let's test all. Let's rerun that with a clean scene. Just make sure that wasn't another issue. We're not deleting a sphere for some reason. Here we go. So 46 tests ran okay, but where we're leaving a sphere here, that is actually going to cause another test to fail because we are looking for a very specific name. We are writing in and essentially saying that this is what we're expecting. But if we already have something named that, it's not going to work. So what's happening is we are leaving it within the test node setup, which we need to actually now make sure we delete the sphere name. Because within the sphere node, we're actually assigning that to the joint name. So the actual sphere that was created has been left in the scene. So we're going to actually go here, create, and just go sphere name. But what we're also going to do is just maybe go over and check that within the dep node. So we'll go to node setter. Yeah, we are doing the same thing. So we're going to end up having the same problem here. Let's have a little look. Yeah, we're assigning 2 items to it, so we won't be able to delete it then in the teardown. Yep. Okay, let's run that there. Here we go. We'll test that in a moment. But okay, so our node setter there is having that deleted as well. Let's press Control S, Control A, Control C, jump over to Maya again. Delete the sphere geo. Clean out your window. and then press Control A, Control V, Control A, and Control Enter. 46 tests ran okay. And again, this isn't running all of these other tests per se. It is just recognizing them and passing without error. So we aren't actually asserting any correct information in there. So if we just delete that, go, select all, and enter, yeah, we're running 45 tests now. That's great. But obviously we're not actually testing anything. Those are just pass. So we need to make sure that we populate all of these with actual test information because we're not testing anything at the moment. I'm sure that's clear, but just in case. Brilliant. Okay, let's test our node path next. What we are testing here is essentially the partial name and the full name. And what we're looking through our OpenMire setup. So where is the information? Here we go. We're testing the partial name and the full name. And one will output just the position of the item, of the name, and the other will do the item and its hierarchy. Okay, let's test the full path as well, and then we'll go over to Maya to test this. Perfect. Okay, so again, we've created our group. We are asserting equal that the sphere full path is now pipe, offset group, pipe, our sphere name. So again, a nice clean way of making sure 100% that our full path has all the information in about the hierarchy of the object, which is, again, an incredibly useful and powerful thing with DAG nodes and DEP nodes independently. I want that the I know it makes no sense maybe why we have full path within DEP node, but that is because the full path of a DEP node is, as it's stated, an item without dependency. And we want to keep that consistency within our code. But now the full path, we need to make sure that it gives us this full path because of with a DAG node, when we're 10 groups down, we need to make sure that our code gets the right item if there are multiple items, which there shouldn't be, but hey. As we are running things into code, we'll make sure of that and check that. So let's press Control S, Control A, Control C. Now head over to Maya again. Press Control A, Control V, Control A, and Control Enter. 46 tests ran okay again, no issues. Perfect. One thing we can do to say make sure it says 40 with the right number of tests that we're actually going through is also maybe just comment these out. So we'll highlight all of these tests that we're not going to do. Let's do shapes next. So we'll leave those unhighlighted. All the way to the bottom. And then we'll press Control and /. And that will add the comments to all of the other tests, which will stop them running. Perfect. Okay, now let's test our DAG node shapes and our DAG node shape. Essentially what we're just looking is for the children of our transform node and just want to make sure that we get all of those. Perfect. Okay, so we are testing now the length within shapes because we know that we only have one shape item below the shape DAG node, well, the DAG node transform. So we are asserting that that is 1. And we are now going to also assert that that first item's name is sphere shape, because essentially within any time you create a sphere node and you rename it, it'll generally then come out with shape within the shape node. It'll change the name of the shape node and also change that shape node's name to having the suffix of shape. So let's have a little look then further down. Now, because we're getting the singular item, we're now assuming that we have an object like a sphere with only one shape node. We are then just going to get that shape name using the same methodology as above. Perfect. Okay, let's press Control S, press Control A, Control C, jump over to Maya, Control A, Control V, Control A, Control Enter. 10 tests ran okay in 0.066 seconds. Perfect. Our code is working really nicely. Okay, perfect. Now let's quickly go ahead and test our children and our all children functionality within our test setup. And I think for this is where actually we're going to now start using our inheritance a little bit more, make it a bit more interesting for us. Okay. So what we're now going to do is we're going to jump back up to our test DAG node. We're going to copy this, scroll right back down, 2 lines, making sure I got a space. Of course you did. You just jumped me back up because you thought that was what I want, but no, that's not correct convention. Okay, fair enough. And then we're going to underscore and hierarchy, because now we're going to test more so the hierarchy around our DAG node. And even then, it will test a few items that don't really need all of this, but because it's all just a few nodes we're creating, it actually won't impede on our speed much at all. So what we are going to do, though, is actually we're going to recreate our setup. And our teardown. It just annoys me that these aren't both the same. Okay, let's fix that. There we go. But because we don't want to overwrite our inherited base node, what we are going to do is we're going to use the Python super, which again, it is going to inherit all the methods and the properties related to our base class. But we are then we're actually then using a method which is already defined. So what we're going to do is we're going to define that setup method right here, and all of those and all of the code that we've written in it. So we're essentially saying, well, please sub superclass, okay, set up the original setup method from the inherited class here, in very layman's terms. But now what we can do is add more functionality. So we'll copy that from both, tear down, because we now want to inherit all the teardown properties and variables and code that we've written. But what we're going to do is we're going to add a little bit more functionality to our DAG node hierarchy tests, because we want to actually have a lot of groups, a lot of items that we can check the order, check the children, the parents, and all of those items. So let's just set up this code here. And now I would say we should press pause. Just make sure you copy, and then we'll talk about all this and what we're doing. So what we're looking at here is essentially the DAG node, which is being created around our first group, which is then encapsulating sphere. So we are creating a group, we're adding sphere to that group. And what we're also doing is then creating 5 more groups, 6 in total. And then what we are doing then is using the mire commands to parent all of those groups to our group 1. And then we're actually going to add a little bit more. We're going to add group 5 to group 4. So we've got a little bit more going on in there. So if you can imagine, we've got group 1, which has got sphere below it. It's also got groups. It's got all of our groups below that. And within group 5, we have added group 4, which probably could be group 6, but first world problems, eh? Okay, now let's have a little look at our teardown, because essentially with our teardown, we'll probably just need to delete a few more items. So let's have a quick look at that. So what we will do is just go teardown, super, and then we should only need to delete if exists, because we still want to be able to delete our sphere because that is being inherited. See, we didn't create the sphere here. This is going to be inherited from our subclass. But we still will want to delete all the other items, and then we'll just make sure we delete all the groups as well, just for good practice. Okay, perfect. Now let's test the DAG node children, which is essentially what we want to do is we want to check that these 5 groups are all showing up within group 1 children. Well, actually, I say this is 4 because we've obviously parented one of these, group 5 to group 4. So there will only be 4 groups, but then there will be the sphere as well that is also there. So there will be 5. So we can essentially assert equal. Let's go with. So what we are doing here is we are saying, well, group 1, which is a DAG node, we are saying, well, let's get all your children. And that'll provide us with the list that is returned. If we go back to our DAG node and go down to children, this is going to return us a list. And from that, we want to make sure that we've got 5 children. So we're going to check the length because we know what it is. We've just set it up here in code. We are then going to say that the first item, or the first child within that list should be our sphere. Okay, let's check all this is working. And let's go Control Save, Control A, Control C, jump over to Maya. Control A, Control V, Control A. And then let's go Enter. 12 tests ran okay. Perfect, amazing, good job. Brilliant. Okay, now let's check all children. So all children really should just be the same, but now should get those extra 2 sub-items. So we'll have one item which is the group, because that is hidden. So we've actually got one more, so 5, 6. And then we're also going to be picking up the sphere, the sphere's shape. So that is going to come back with all of the children. So we'll change that up to 7, which I believe is true, which I believe will work. And let's jump back to Maya. So Control S, Control A, Control C, and Control A, Control V, Control A, and Control Enter. I'll stop saying that now because it's annoying me. Ooh, session error 5. Of course, because I changed the code. But I didn't say all children. I just said children. Let's go back to Maya. Okay, highlight all and press Control Enter. 12 tests ran okay. Perfect. Amazing. Okay, we're flying. That's good. Let's go through parent now and all parents. Okay, great. So let's highlight our code and then we'll press Control / to uncomment. And now we just essentially want to check what the parent is of one of our items. So if we say that group, we need to create a DAG node. So we've actually parented group 5 to group 4. So let's use these two. So group 5. Which we will create as a DAG node because it is not yet. And then we will say parent equals DAG node group 1. Not group 1, sorry, group 4. Perfect. Okay, let's say Control S, Control A, Control C. Control A, Control V, Control A, Control Enter. 14 tests ran okay, perfect. Okay, now let's test all parents. So if we're again going for 5, which is the lowest in the hierarchy, let's see what we get back. Okay, so now let's have a little look. So group 4, that is within group 1. So it just has one parent. The group 5 is within group 4, that is within group 1. So it has 2 parents. And I think that's pretty straightforward. Now let's test our order and reorder. We'll actually put these together because their functionality is kind of intertwined. Okay, perfect. So what we are checking here is that the order, we know that it's the first item within our groups because it's the first item added to group 1. So we're going to say that the index item of that is 0. We're then going to reorder it by 3 and then assert that it has been reordered to the point 3. Okay, so we're checking our order twice, but then we're also checking our reorder because reorder will have, if reorder has worked, then it will be in position 3. And if it hasn't, then reorder is broken. Now let's test our parent functionality. Okay, perfect. So within our parent 2, we are going to move the sphere and parent that to our joint. So now we should, in theory, within our sphere, be able to say self.sphere.parent, and that should equal our joint. That should be the same item now because we're jumping up in the hierarchy. Now let's parent to world. Okay, perfect. Let's keep everything nice and compact. What we're looking at here, we're kind of using all parents again. So as long as that's passed, that shouldn't screw this up. And what we are, again, using is just our logic because we know that, again, our sphere has one parent. It's in group 1 within this test class. So we're testing that that's 1. But then if we say sphere parent to world, which is just going to literally put it at the base of the hierarchy within Maya, we are then going to say, well, okay, how many parents have you got? 0. So let's run all of these. Let's press Control S, Control A, Control C. Jump over to Maya, Control A, Control V, and then Control A and Control Enter. 17 tests ran beautifully. Look at all those dots, gorgeous. Okay, great. I haven't got any errors yet. No logical errors that I can see, or that I can think of yet. Let's test our next few items. We're getting through them. We've still got quite a few, but we're busting through quite quickly. Okay, let's test node moves to. I might start actually skipping forward in this and just writing out the code, and then I'll come back and explain it, just because, again, we are already getting to about an hour within my video recording time. Okay, perfect. So we've got our test move to. And this is testing that the method works, takes the arguments, and it moves as expected. So if we essentially move our sphere, we're going to use the full path. Again, we've not got any attribute setter, so at the moment we can't go .a, .tz, or tz, sorry, set, which is the Pythonic way of doing it, which we're going to make in our next lecture, and I prefer to do. But we're going to test more of the Maya commands here, just to make sure that we're doing everything we can just to test the node as it is at the moment. We don't want to test attribute functionality, say within our DAG path, because we haven't, that has not been made yet. So we want to try and test everything as localized as possible. In the future, you could come back and refactor this, but then if you have an error in your attribute code, it's going to actually throw off all your test cases in here. So I would say probably best to leave everything as Maya commands running, even though in the future you might have more code which works in a different part of your hierarchy. So first we're moving our sphere in TZ and 100 units. And then we are going to assert false that the sphere is in the same position as the joint. So we're using xform, which again is going to give us the world space translate position. We are querying that, and that was returning us a little list of the translation of the translate position, which is now false because it is not in the same position as the joint. We are then going to get the joint, and we are going to move that to the sphere. So we're saying move to sphere using our match move functionality. And we are then asserting true that the xform now is saying that, well, these items are in the same position. We're testing that the joint and the sphere are getting the same xforms of the same transform within the xform functionality. Perfect. Okay. Now let's move on to go to move here, which is going to move items to one place. Pretty much the same way. So again, we're moving our sphere. We're asserting that the position is not the same again. And then we are going to essentially move the sphere to the joint, and then assert that they are both back together in the same position again. And then with the DAG node offset, this is again using the parent functionality, so it's very similar. I think if we look back and we go down to offset, offset is just using parent, but we might as well make sure that that is just all working correctly, because generally if we're going to get an error, we're going to make sure we're going to get an error with offset and parent, but it'll just remind us to check that if we do get that error in the future. So we are testing that the offset of group 5 is group 4, because it is embedded right there. Okay, let's highlight all. Now we're not going to make that into a DAG item. Let's see what happens. So Control S, Control C, Control S, Control A, Control C, and then jump into Maya, Control A, Control V, Control A, and enter. 20 tests ran. Brilliant. Perfect. Okay, what we're getting here is we're going to assert equal that the length of all parents of group 1 is 0, because we know that group 1 is the base object. We've created that as the first group that all other groups are parented under. We are then going to go self group 1 create offset. Okay, awesome functionality, which will move a group to underneath that in its exact position. And then we are going to assert equal that the that off group is also that we then have an extra parent below our group 1. So we are checking that we've made a group and it is within the hierarchy. And then we're going to delete the group at the end. Okay, let's move on now to our get constraint information. Let's highlight to uncomment all of these. So highlight everything down to, oh yeah, there's so many of these. There we go. You know what we might do? Because we have get constraint, we're going to test that, but where we're getting geometry constraint and we're also creating a geometry constraint, we're going to actually double these up and put them together. Because, again, their functionality is intertwined, so it just seems a little bit more logical to do that. So let's go ahead and delete everything here. We'll still test maybe parent scale, make sure that's running as expected. Okay, let's copy all of these up to here. So the geometry constraint, which creates them, all the way through down to the scale constraint. And press delete. And now let's have a quick little look. We'll remove that from that double underscore because it's not a dunder method. And now we're going to use Maya commands to essentially create a parent constraint, just so that we can test it. We have tested with the security of knowing that Maya command should be running correctly. So creating a parent constraint on the self.join, and then we are going to say, from self.join to self.sphere, and then we are going to say, well, self.sphere get constraint. Again, not a method we should be using outside of the class, but something that we might as well just test within our test capabilities, and that is of type parent constraint. And assert equal that our constraint is equaling our expected result, the constraint that we are returned from the command. Control S, Control A, Control C. With a nice clean scene, we will then go Control A, Control V, Control A, Control Enter. 30 tests ran. Okay, that's great. Brilliant. Okay, and now within our geometry, get geometry constraint, let's run with some similar functionality. Let's copy over the functionality and then rewrite this out. So we've got our expected result again, which we are going to say self.sphere, a dot geometry constraint to self.join. And then we are going to say, well, okay, let's get that geometry constraint now. Save that as a constraint, and then check that these two are equal. All right, let's check that it's all working. Control S, Control A, Control C. Jump into and open up Maya. Control A, Control V, Control A, and enter. 30 tests ran. Perfect. Still no errors. All right, let's copy that down and do the same for the next. Let's do the same for aim constraint. All right, great. So we are again going to test the get aim constraint property, the aim constraint method, and we are going to check that the output is similar. So again, nice and simple. We are just going to keep busting through these one at a time. Let's go through and do the rest. And then once we get down to get scale constraint, we'll probably just we'll get these tested. From our geometry constraint, aim constraint, or in point parent, you see we're testing each one of the methods properties and its method for getting. So make sure you update all these names. And then what we can do actually is we'll just click on the test function name on each one of these. Just to make it clear, we will go underscore getter and setter, which not in the common kind of usage of getters and setters, but we are setting it and then we are getting it in the way that we need to Pythonically for how we will work in Maya. Okay, let's scroll down. Oh, you missed one. So got scale constraint, get scale constraint, and then, okay, let's quickly highlight everything and test. So Control S, Control A, Control C, jump to Maya, Control A, Control V, Control A, Control Enter. 30 tests ran with no errors. Beautiful. Okay, not too many left now. We're flying through. This is great. And now we're going to go test DAG node weight test DAG node constraint weighting attributes. So now what we want to do is we want to use our parent constraint functionalities within the DAG item. So group 1 DAG item, parent constraint. And then we want to use the parent constraint functionality, which is going straight through to my commands. And we are going to be essentially using these 3 items to parent group 5. So you'll have all of these attributes underneath, as we showed earlier within the DAG node. And we're going to get all those connections. And now there should be 4 connections in theory, because we've got group 1, group 2, group 3, group 4, all parent constraining to group 5. So that should be 1, 2, 3, 4. Let's assert that is. So we're doing a different one here. We're also asserting is. So we can just like assert equals, you know, might as well live on the edge and try a different function. Okay, Control S, Control A, Control C, jump to Maya, Control A, Control V, Control A, Control Enter. 30 tests, all dots, all beautiful, good. Now let's test our parent scale let's see, I think I feel like that's in the wrong position. Where did we put that down? DAG node. Let's jump down. Ah, of course. Yeah, not of course, actually. Oh, of course, yeah, because we've copied everything above. But then the parent scale constraint is underneath. So we'll just test that functionality as well quickly. Dev node and DAG node. So let's test the getter setter there. Or actually, not so much the. Let's actually test the parent constraint, because we know we're actually only returning the parent constraint, if I remember correctly. Parent constraint, yes, that's what is being returned, the output from the parent constraint. So we are going to parent scale constraint. And we can actually just do both, couldn't we? We could get scale constraint too. So we've got our expected result and our constraint. And now what we're going to do below is we're going to get our scale constraint. And what we might need to do is actually hard code that in. So let's run this and see what error we get. So let's go Control S, Control A, Control C. And then let's run that. One failure, expected. Yep, that's what we want. Perfect. Because that's what we're essentially testing for. But what we're actually looking at is the scale constraint, and that's the name of it. So we'll use that within our test. Expected result is there. Perfect. All right, now let's test our color functionality. Perfect. So reorder these a little bit for color, set color, and color as a string. So we've got our getter and our setter. We are going to set the color to red, and then we are going to set that is number 13 within our names. Red 13. Beautiful. And let's jump back to DAG node. So I'm just going to close the dep node. We don't need that. We've got a lot open. Let's make sure we don't keep on jumping into the wrong window. Then we are going to assert light blue. Oh, sorry, set color to light blue. And then we are going to get the color as a string, which is kind of already testing this. And then we are going to assert that we get that back. And then we're going to do the same below for our color as a string. We are going to get, we're going to set our color as red, and then assert that it's red, set that our color is blue, and then assert that our color comes back as blue. Okay, easy as that. Now let's do Control S, Control A, C, and jump back to Maya. 30 tests ran all beautifully. One thing I will say is I think I noticed when closing our scene before, yep, no, it's still there. And I changed it back, and then I thought it would run up, but I still have Maya open. We set the color name wrong. Well, I set the color name wrong. I've done American color, which obviously we're in the UK. I'm in the UK. You can set this name any way you want. But for consistency, this needs to be, yep, now I see it's picked up the usage. It needs to be get color. Because otherwise in DAG node, get color will not be picked up. So it won't be that useful. Okay, perfect. So there's that little issue sorted. Now let's go for our last few setups now. For set visibility, show and hide, these should be pretty straightforward for the methodology. So we're going to check our methods here for set visibility, which we are going to set to 1, and then we are going to assert using Maya commands our full path and v with 1, set visibility again to 0, and then assert that within Maya commands we're getting that back as 0. And then with hide, we're going to pretty much do the same thing. We're just going to use our shorthand for hide, check that it's 0. And then for show, we are going to use, we're going to essentially show hide that is 0, so confirming that our item is hidden. And then we are going to say show, and then confirm that our item has been set to show. Okay, let's press Control S, Control A, Control C, jump to Maya. Control A, Control V, Control A, Control Enter. 39 tests ran beautifully. Great job, everyone. Okay, now let's check the history, the delete history, and the duplicate. What we are doing is we are checking the property for history, and we are essentially just making sure that within that newly created sphere that has only just been created, as we've called this new test, that we have the node connecting to it with its build information called polysphere. So we're going to have an assert, and we're going to assert that that is within the DAG node of the and within the history, which should list out DAG nodes of the shape and the history node. And then we are going to test that we are deleting that history. So we're going to go self sphere delete history. Then we're going to say history and assert not in. We're going to assert that polysphere. Actually, that'll be a none type then, because it isn't in there. Is not, polysphere is not within the history of the items. We should probably assert the length. Actually, we'll come back to this in a minute. We'll see what happens with our test. So let's go Control S, Control A, Control C. Jump over to Maya. Control A, Control V, Control A, Control Enter. I think I've seen an error. Yay. Okay, we've got a couple errors. So delete history. And history. Interesting. So the method is not iterable. Okay, so we argument type of method is not iterable. What we have not done is said that our history, we've got a history function here. We actually want a history property. So we want to say at property. And then we are all good to go. So that should then be working. Perfect. Okay, let's save that. Okay, let's save here. And now let's reopen Maya. So close Maya, don't save, and then reopen. Great. And once your Maya has loaded, let's again copy all of your code, open up your Maya. Copy all your code into your Maya console, select all, and enter. Now let's see what errors we get now, if any. 39 tests ran. Okay, brilliant. So it was literally just our issue of not setting history to a property. That was causing the issues there. Perfect. Okay, so delete history is working as well. So again, we're just deleting all the history from an item and then asserting that polysphere is not within that item. Because up here, we are asserting that polysphere is within that item. Let's just test actually it works without, because we want to make sure that we have consistency within our assertions here. So let's have a little look. Copy all. Move back over to the Maya window. Run that code, 39 tests. Yep, that's okay. Even though all the items in there are being checked, obviously iteratively, and they're being turned into strings. So that is perfect. All right, let's test our duplicate. Now we want to kind of test actually here the duplicate, maybe we want to test that it passes, and we also want to check that it fails. So let's have a little look here how we can test that. Okay, perfect. So here we are. We've got our duplicate pass. We're going to test that the item does get duplicated. Got our test item name. Okay, then we have sphere item 2, or sphere 2, and then we're going to equal that to the sphere dot duplicate and then the new name. So what we're going to do is we're going to assert true that that item exists. What we're doing here is we're also going to test that our full path is offset and then the test item name, with the pipes obviously showing which level you are at within the hierarchy. And then we're going to delete the item and then assert that it doesn't exist anymore, assert false. Does it exist? False? No. Okay, we're asserting that. Great. Okay, now let's see what happens next. We're going to assert that fail as well. So we're going to say delete our sphere, and then we're going to use this fun little bit of code which asserts when raised that we get this error. We're going to get a value error because we're going to go self sphere duplicate with the name test, and that will raise a value error. And then as CM, we are essentially going to save that error out and attest that we are getting this output. So this is the error that we are raising down here. We need to make, and we want to assert that we are getting that error. So it's a value error we're raising. Okay, we're testing that we get a value error, and we're asserting that we get the output as well. Great, let's copy all. Okay, press Control S, Control A, Control C, jump back to Maya. Control A, Control V, Control A, enter. 40 tests ran without error. We have tested everything within our group. Okay, you guys are amazing. This was not easy, and this is probably the second biggest test class and module that we're going to have. The attributes setup is far more in depth in this, because obviously what it handles is more of the minutiae of Maya. We need to append, add, edit attributes, and that's what we're going to be moving on to next. But amazing work. I'll probably add an example of how we can use this code in the next lecture, but you guys are amazing. The fact that you've got here has jumped you forward in your careers massively. I was writing Python and writing functions in Maya about 3 or 4 years before I started actually writing this, or 4 or 5 years maybe. Before I started again, I took some time off after a few contracts and just did loads of Python tutorials. Did some Django tutorials. Again, like I said, it's awesome. And then I've started then copying over a lot of that info, a lot of that methodology over to Python. And I worked with some amazing people as well. Thank you so much for listening, and I'll see you in the next lecture.